Hi everyone, in this segment we are just going to be doing an overview on the factors that affect acidity, just kind of building up to looking at ultimately how these factors play a role in determining relative acidity between species. So we have a number of factors determining and playing a role in acid strength as well as, conjugate base stability. And you can kind of break these factors down into factors that pertain to the atom bearing the acidic proton. I know we've used this generic expression HA. So we would be saying, let's look at factors that pertain to the atom bonded to the proton. Those factors include electronegativity, atomic radius, which is generically referred to as size, and hybridization state. And if you're making a comparison between acids, and it is the atoms that are bearing the acidic proton that differ, we can use these factors more than likely to differentiate their acidity. Okay. We also have factors that pertain to electronic effects that affect acid strength. So if we come back to our generic example of HA, there might be something else in the structure. We'll say some other structural component Z, and we're thinking about how that other structural component affects the acidity of our hydrogen, and also how that other component might affect the stability of the conjugate base. We'll find that looking at conjugate base stability is an excellent way to gauge relative acidity between species. So let's say you're making a comparison between two acids, and the atom itself that is bearing the acidic hydrogen is the same. For instance, you may be looking at two acidic hydrogens. They're each bonded to oxygen. If the atom is the same, it is likely something else in the structure affecting the acid strength and the conjugate base stability. We are going to then think about electronic factors, and those electronic factors can either be pi effects, or we could say there is a resonance effect, or we could have an inductive effect. And inductive effects are sigma electron effects. Now, I really want to stress that because there are two types of electrons, pi electrons and sigma electrons. And we will differentiate these factors, these electronic factors, by the type of electron density that is being affected, okay? Whether the electron effect is inductive or resonance is pretty consequential, and you and I will differentiate that probably a little bit more than you'll see in your textbook or in other resources, but I assure you, if we think in this way, you are ultimately going to get more questions right. So seriously, no joke, take whatever time is necessary for you to drill these factors into your memory. The next video segments will be going over each of these, one video per factor, and I really, seriously, no joke, want you to take the time to drill these into your memory, because ultimately, developing a nuanced understanding of acid-base chemistry is crucial to your success in this course. Now, later we'll be learning hella reactions, lots of reactions, not just acid-base reactions, other reactions. But at times there are steps in those reactions that are acid-base chemistry steps, or we could say proton transfer steps. And to be able to understand the dynamics of these reactions, you need to have acid-base chemistry down and be able to consider the factors that affect acidity. Hang tight. We're about to get into that.